Gravitation, gravitation, gravitation. What is that gravitation? Hi friends, welcome to the gravitation given by Brahmaya. Today I would like to discuss the Kepler's laws. Kepler's laws, first law. Law of orbit. All planets revolve around sun in elliptical orbits with the sun at one of the foci of the ellipse. So, see here, this is the elliptical orbit. Elliptical orbit. This is the one of the foci. Sun is located here, or this is the here. Let us consider this is the center O. This is A, one of the position of the planet. This is the B, another position of the planet. The nearest position or nearest point from the sun is called the perihelion. This point is called the perihelion. The longest point from the sun is called the aphelion. The distance between these two, that means the shortest distance between the sun and the planet. This is the position of the sun, planet. This is the position of the sun. The shortest distance between the sun and planet is called the perigee. The longest distance from sun and planet is called the apogee. This is called the apogee. So, here we have to know that eccentricity E. So, that is given by the ratio of SO to OA. This is called the eccentricity. Then SO equals to E into OA. So, this is the semi-major axis. OA is nothing but A. So, then SO equals to A into E. A into E. So, let us here, nearest point from the sun of the planet is called the perihelion. Longest point of the planet from the sun is called the aphelion. The shortest distance between the sun and planet is called the perigee. The longest distance from between the sun and planet is called the apogee. So now we want to find out the perigee. So how to find out the perigee? So look at this. From this perigee. So this is the perigee. So I have to write OA minus OS. So for finding the perigee, that equals to OA minus OS. OA is nothing but A. OS is nothing but AE. Already we calculated here. This is the SO or OS. So now we have to take A is the common here. 1 minus E. This is the perigee. Similarly, apogee. We have to calculate here. So, see the figure, apogee. Apogee, I have to write SO plus O. This is the B. SO plus OB. SO plus OB. So, apogee equals to SO plus OB. SO equals to, SO is nothing but AE plus OB is nothing but A. So, here A will take a common 1 plus E. So, this is the apogee. So, this is regarding about the first law of Kepler's first law or law of orbits. Now we have to go to the law of area. Second law, Kepler's second law, law of area. The line joining the planet to the sun sweeps out equal areas in equal interval of time. Or aerial velocity of radius vector is constant. Aerial velocity of radius vector is constant. So let us see the diagram. So this is the elliptical orbit. This is the sun, one of the position of the sun. So we have to take a, while the earth is the planet is moving, this is the orbit. If it is moving from A to B, how much time it will take? Same time it will move from C to D. The time period of time taken from A to B is equal to time taken from C to D. So this is called this is the law of area. So that means here how much area it is called, the time taken to travel from A to B, how much time, the time taken travel from C to D, that is the same. So that is also we have to say that here aerial, how much area it is covered to travel from A to B, same area it is covered to travel from C to D. So this is, we have to prove it according to the law of conservation of angular momentum. Law of conservation of angular momentum. So look at this. According to this, if I will consider this is the small dt, right, theta angle, I will consider this is one of the right angle triangle. So approximately, not exactly, approximately I will take a right angle triangle. Then this area is look like a area of the triangle. Area of triangle. Area of triangle. So that is, we have to write, we have to take a TA equals to area of the triangle. We know very well about that, half into base into height. So 1 by 2, base is nothing but radius. So this distance I have to write radius into dt. R into d theta, we have to write R into d theta. So then that equals to 1 by 2 R square into dt dA equals to. So look at this. This is the area, change in area. I will take a area by time. So aerial velocity, rate of change of area. Rate of change of area is called aerial velocity. So dA by dt is given by the aerial velocity, that equals to 1 by 2 r square d theta by dt. So this is nothing but angular velocity. So we will write 1 by 2 r square omega, we have to write. Similarly, 1 by 2 r square v equals to r omega, then omega equals to v by r. So if I will substitute here v by r, this r and square get cancelled, we will get it 1 by 2 vr. If I will multiply here m by m, if I will multiply here m by m, what I will get it here? This is mvr by 2m. So dA by dt equals to mvr by 2m. This is nothing but angular momentum. Right, dA by dt equals to L by 2m. So here L is the constant, angular momentum is the constant. If it is the constant, so this is will not change. This is will not change. So this is the angular momentum is the constant. So that's why it is not changed. Angular momentum is conserved. So dA by dt is a constant. Okay na? So it is followed by the law of area. It is followed. So this is regarding about the law of area. So now last one is law of time period. So what is the statement? That's the time period of revolution of a planet is proportional to the cube of the semi-major axis of the ellipse traced out by the planet, or the average distance between the sun and the planet. So let us hear. This is semi-major axis. This is semi-major axis. So according to the statement, what it is given? T square is proportional to the cube of the semi-major axis. This is the law of Kepler's third law. So first law, what is the first law? Just we have to recap very quickly here. All the planets revolve around the sun in an elliptical orbit with the sun at one of the foci of the ellipse. So this is perihelion, aphelion, perigee, abogy, eccentricity. Next one is law of area. Aerial velocity of a radius vector is a constant. Aerial velocity of a radius vector is a constant. So, and the third one is law of orbit. T square is proportional to the R cube. Sorry, A cube. A is the semi-major axis.